We begin with the definition of probability. The probability of an event is the number of outcomes in favor of an event divided by the number of possibilities in observing whether that event occurs or not. Now, an event is something excuse me, that happens that you can measure. For example, if you flip 14 coins, do you get at least 10 heads? The event is getting at least 10 heads. The probability of that event is the number of outcomes of 14 coin flips that have 10 heads, that is the number in favor, divided by the total number of possibilities, which is the total number of outcomes that you can get from flipping 14 coins. And the probability is the number in favor is called n of e. The number n of ways that that event can happen. Okay, n of e is the number of ways the event can happen. N of u is a number of occurrences in the universal set, which is called the sample space. Excuse me. The idea of a sample space, again, if you flip 14 coins, the sample space is a list of all possible combinations of heads and tails, actually all permutations of heads and tails that you can get on that experiment. A picture of probability is a universal set of possibilities with an event being set within that universal set. If we flip 3 coins, the event that we're looking for, well, the question is how many ways to get at least 2 tails. Okay, so the event is getting at least 2 tails. That would mean we'd get either 2 tails or 3 tails. At least 2 would be 2 or 3 on a flip of 3 coins. In this case, what do you think the universal set is, and what do you think the set of outcomes favorable to the event would be? You might think about that before you go on, and let's look now. The universal set is a set of all outcomes that you can get in flipping 3 coins, and you should be familiar with that from previous chapters. Just listing heads, 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 down through tails, 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 all 8 possible results of flipping 3 coins. The event that we're looking at is getting at least 2 tails. We can actually see that event within the universal set. I've kind of underlined them lightly. Heads, tails, 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 heads, tails, 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 heads, and of course tails, 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 which for some reason I didn't underline previously. These are the events, or these are the occurrences that are favorable to the event. So that is those occurrences put together into a set is going to comprise your event. Now the probability of the event is what? It's the number favorable to the event, that is the number in the set E, which is 4, divided by the number in the total set, the total number of possibilities, 8. And that's 1/2. Okay, again, we see that that's the number in E divided by the number in U. The number of ways the event can happen is 4. The number of total possibilities is 8. 4 divided by 8 is 1/2, and that's our probability. The probability of getting at least 1 heads, just as another example, with this sample space, well, what is the probability of getting at least 1 heads on a flip of 3 coins? The probability of getting at least 1 heads is the complement of the probability of getting all tails. In other words, if you don't get at least 1 heads, that means you got all tails. So the probability of getting at least 1 heads is 1 minus the probability of all tails. Now 1 is the probability that you get if an event is certain. Okay? And if you add the probability of getting at least 1 heads to the probability of getting all tails, you get 1. Because these events are mutually exclusive, that is, you either get this or you get this, but there's no overlap, there's no intersection between these events. And also, all possible events are contained in the 2 occurrences. Getting at least 1 heads or getting all tails gives you every possibility. In any case, Probability of getting at least one heads is 1 minus the probability of all tails, which is 1 minus 1/8. Because getting all tails, there's only one way out of 8 possibilities. So we have 1 minus 1/8, or 7/8. As another example, if we've got 2 dice, we can list the universal set, the sample space for 2 dice. Okay, we got the first die and the second die. We could get 1, 1, 1 in the first, 1 in the second, 1 in the first, 2 in the second, 1 and 3, 1 and 4, 1 and 5, 1 and 6. Or we could get 2 in the first and 1 in the second, which is certainly different than getting 1 in the first and 2 in the second. Or we could get 2 in both, and so forth, up to 2, 6. And then we list 3, 1 through 3, 6, 4, 1 through 4, 6, and so forth until we get down to 6, 6. We have a nice regular listing here. Now, out of this sample space, what's the probability that we're going to get a total of 7 on the 2 dice? Well, to get a total of 7, we can look at the sample space. We could get 1 and 6. We could get 2 and 5. Now, I haven't listed them all, but we could come down here. We could get 3 and 4, 2 and 5, 1 and 6. Okay? And those possibilities, if we had the entire listing, would run along the diagonal of this array that we've got here. So there are a total of 7 ways, total of 6 ways that we can get a total of 7. And we've listed them here. Again, they correspond to the diagonal positions on this listing. So the probability of a total of 7 is the number of ways favorable to the event, n of e, which is 6, divided by n of u, the total number of things that can happen, which is 36, reduces to 1/6.